I am Yuriy Polyulya, and I am software developer in Birthday company. And today I want to talk about arrows. This material it's not new. I think it's about 20 years old, but I still not see that arrows in Scala code, and really hard to find a repository on code was use arrows. I hope it's because not it's a bad conception, because it's not popular conception, and I want to introduce it. What is arrow is? Maybe how many people know about arrow and maybe work with it before? Okay, yeah, cool. Okay, let's start. Motivation for this presentation is fairly simple and is represented by two words, by two most important ideas of modern vision of functional programming. You hear, I think you hear it here during the 2 days, but I want to repeat it first. It's all begins from the data, and then a relation between the data structures, and this relation, it is what a program is. Yeah? And second, it's no program that can be defined in the form of pure function, and this is why we always should be concerned about side effect. Yeah? It means that we have a data what's represented by structure, and program it's relation between the data, and our program, no program without side effects. Yeah? And this is a goal. This is what motivates me to do that, and goals is to show one of possible techniques of managing of your data and control your side effect. Few words about a function. I think we have two objects with different types, with relation between, and relation, this is a function from the string to integer, and this function can be notated like an arrow. Yeah? In most science paper you can see that arrow, what's this relation between two objects, and namely it's a function. And in what follows, I suggest to use a block diagram for the function representation, and it's only for convenience of the image, but still we refer to it as arrow or function, and simple function in Scala in the bottom of the side. You can see, yeah, it's a function. But maybe the important part of the function possibility is composition of the function, and function composition, here is I presented a diagram, and block shows that the function composition should be considered as a function. It means that composition to function, it's a function for future. And this is what we have. This we have in Scala framework out of the box. Yeah. In other words, that Scala predef provide a few function combinators. It can be looks like a high order functions. Few initially it's one and it's compose, and then it's reverse for compose, but few. Yeah. And if we have a high order function, would be reasonable to use high order function for all features of high order function in full power. And maybe that it's a very good words. Its combinators are well described in few words of John Hughes in his article, and I have nothing to add. Maybe that a function which builds program fragments from a program fragments. Yeah. As you remember, we began our conversation about data structure, so I would like to continue with them, and let's look for some of common data structures. Yes, and first will be a product. I would like to note that in functional programming world, and in terms of category theory, that it's more correct to describe any types by a function exposed by those type. It means that object represents by structure, data represents by structure, and type represents by function, what's related to the types. Yeah? In other words, by methods of interaction with those type. Okay, back to the required product type. If we look to the diagram, yeah, this is a product type. It will be right to say that it's a data type for which the relation in diagram is correct. Yeah, that next relation, that a product, I will show that product function G, it's something like a product function composed with first, it's a special function what exposed by this type, should be equal to function f. And in Scala, this type represented by tuple. Some code where I prove that my previous time statement about tuple is true. It means that here it's some tests that prove that tuple is a product type. Okay. As we define a first common data type, and the next step is use this data type for our combinators. And I think first will be a split combinators that I use two names here. It's one is a split function, yeah, and this is a common name in the Haskell. You can find it in the Haskell or in Scala Z implementation. What these combinators do? Yep. It's combined to function so that a parameter of final combinator will be doublet or tuplet and applied for two functions f and g in parallel, and result type is a product of function results. Yeah. In other words, tuple of f and g function results. And Scala sample below. Here we have two functions f and g. Yeah, and function h was split f and g function, and if we apply law, yeah, we have result of first function and of second function here, like a tuple. Next one is combine combinator, and it's close to first one, but combinator's argument is a tuple, and result is tuple too. And you see that input is a tuple, output is a tuple, and if we have to function f and g and apply some tuple for final function h, we should have a first function result, and here it's second function result. This is a Scala implementation of arrow type class. As you can see, that arrow type class is subtype of category. Type class should be, because composition of function is a property of category from any point of view of category theory. And we will back to category properties a little bit later. Next base type which I want to consider, it's a coproduct. And if you remember previous diagram, yeah, for product type, then it's not too hard to notice that it's all arrows in diagram are reversed. And as before, for type definition, I offer to define it in a way of interaction, yeah, and namely that relations in this case. We have a coproduct function, and this coproduct function result should be equal to composition of f and left or h and right. In Scala, this type represented like either, maybe that more closure representation set. We have many different representations in different frameworks, but if we choose a predef, it's either. And some proof, code was proof of my previous statement about either. It's true. Yeah. Okay. Next, as before, we made for tuple, and now for either type we can define the also special combinators, which will simply use for function with either an input and output. And first, it will be a multiplex combinator, yes, and take into account internal specific of either type. our multiplex combinator combine two functions f and g with next application strategy. F will be applied for a left type of arguments and g for right type of either. Yep. And a sample code here. We have f, what's a string integer, g, what's int string, some implementation, and multiplex to these two functions. And if left, hello, we have a length. If we have a 5, we 5 times have a minus. Yep. Next combinator is a merge. And essence of it is combine two functions so that for a left and for right we will be applied accordingly f or g function which has the same as you see result type. Yeah. In other words, it's a folding function which encapsulated left and right morphism for our either types, and a Scala code here. Yeah. The same example was before, but result it's not either as before. If you go back here, with result was either and left and right, and here we have final type 5. Okay. This combinator is a part of arrow choice type class and Scala implementation of type class here. I do not consider the details of the Scala syntax extension implementation, since that extension are rather templated and implementation is enough common. Yeah? I just look into the initial essence of type classes. Yeah? What method we should to have. Okay. And now it's time to summarize what is arrow. Yeah? And arrow is a generalization of function which provides a more function combinators. It means that in framework we have a 1. With arrows, with arrow type classes, we have a little bit more. First, second, split, combine, as you wish. But it's not at all about arrow. Next kind of arrow, it's a KLEISLI arrow. And I would like to return briefly to category theory and its properties and how it's looking in Scala. Yeah? It means that for any object type, it should be possible to lift this type in category. Yeah? And for option type, it will be apply method in companion object. It's common known. Also, it should be possible to lift relation between lifted types in our category, and for option type it will be a map function. Yeah, it's what is category and what is object, what is relation between object and how it looks like in category. And for KLEISLI category, this is a diagonal arrow between two objects in primitive types in it and another types in category. Yeah, this is what is a KLEISLI arrow is. It means that before we saw that simple arrows between the simple types, this is the arrow with the types what begin in simple types and have end in the categorical types. And for KLEISLI arrow, it's just enough to reverse this relation. Yeah. Little introduction about the KLEISLI. Type class for KLEISLI arrow. But I would like to digress for say thank you for Eric, who developed a kind projector plugin, and it's really simplify lambda notation. Yeah, you can see the KLEISLI type class with this kind projector. You can find it in the HitHub, and you see that for KLEISLI, if I have a KLEISLI definition like that, yeah, that it's for KLEISLI category was I should have a M, and this will be a category and lambda. But with a kind projector plugin, I can write this simple. I really impress these features, and I think it's very good for library developers. You not need now to write this long code with lambdas. Okay, back to the KLEISLI arrow. Yeah. Initially we define, but what is M? It's only option, or it can be something other. Okay. Any function has, any mathematical function has one parameter and one result. Yes. Everything else, and this is name is like effect of function. Yeah? And everything else it's a side effect. And general idea is to wrap side effect to container. In other words, localize it for a generalizing of way to process with a side effect wrapper. And namely, what kind of side effect containers do we know? I think it's very common known. Maybe that first one is what's mostly common used. It's a list, yeah. When function have a more the many result, more than one, or maybe nothing, yeah. Sometimes we have no result, it's option, yeah. Maybe result it's postponed, or maybe no result in future. Write it to the logs, read from environment. It's all the containers for side effects. Yep. And once we started talking about the side effects, it would be good to decide on way to work with a container with side effects. Yeah. And first one, it's a monadic way, how to process with side effect. And the essence of this monadic way can be easily represented, but next two lines, yeah, that we have a functor possibilities when we transform a simple function to categorical function, and monad it will be flat map. This is map. This flat map. Transform a KLEISLI function to the function in category. But it is not only one way to do that, as you might guess. KLEISLI arrow is a second one, and one of the advantages of KLEISLI arrow, this arrow built a container for a whole function with side effect. In case of monad, it's just to give a command structure. It means that it's wrap side effect and provide a way for, for apply something for side effect, but not compose. Yep. For example, let's consider the following data. Yep. And we have some case class, few functions. Yeah, in any case, it will be like a KLEISLI function. Yeah, get user by ID. It's from database. It can return none. Update user in database. It also can be return none if, for example, if you update an unexist user. And to function update name and update password. Update name, it's something like a composition of function validation and update of some of parameters, because here it's expecting string after user and have an option maybe if it's, for example, if name it's empty, I have a none here. For example, if password is the same like before, I have none here, something like that. And here it's two ways, yeah? How to do it in monadic and how to do it in KLEISLI when we use. As you can see in first implementation, we should wrap our monadic function, yeah, here. When I call this update with user, I want to update name and password, and I wrap my monadic implementation to the function. But in second way, all composition looks natural. No, maybe not so natural, because here is some interesting operators, but it's a composition always, yeah, for KLEISLI arrows. Okay, it's time to define implementation of KLEISLI arrow and KLEISLI arrow type class, because I just showed the previous one. General. And I can say that the simplest implementation of KLEISLI arrow will be based on monad implementation. It means that if monad already defined for your type M, then KLEISLI arrow not need to additional efforts to implement it. It means that you can combine function with a side effect without any additional efforts if you have already defined monads. And arrows as is, but as we expect that arrows it's a part of framework. Yeah. But I would like to go back to the arrow and show that they are still self-sufficient and show how to implement monad based on the arrow. And here is some code. What shows that code is not important. That important idea that monads can be implemented by arrow. That it means that if I have implemented arrow, I can implement a monad with zero effects, with zero efforts. Yep. What here before I used two type class. I add two type class. It's arrow apply and arrow monad. And what is arrow apply? It's by analogy of high order function. This is high order arrow. Arrow where first argument is another arrow, and second it's a value what I want to apply. And second one it's arrow monad. It's arrow where first argument is empty type. Yeah, where we start with nothing. It's something like a point. And as we have shown, these two arrows can be implement monad into any monad interface. It means that we can implement point and flat map with these arrows. I want to back to the KLEISLI arrow and some properties of arrow type class, and based on parameters of this type class. It means that if all parameters is not defined, it means that it's kind of this type is fully undefined, it will be a KLEISLI arrow. Yeah? But if we have some, for example, for our type constructor M, we has monad instance, yeah, that our KLEISLI arrow has the same kind like arrow, and it look like arrow, and behavior like arrow, yeah, if we have monadic instance for our M. If we have, next row is, if we have functor instance for our F, yeah, F for A, it means that type reduced and type that looks like a functor. Yeah, similar type it's a functor and behavior like in functor. And if we have a monoid instance for F, yeah, like it's for FB, for AB, it means that monad instance for FA and monoid for FB, then type is fully reduced and it will be a monoid for any type A. I want to little bit summarize all what I said before and summarize maybe the idea is summarize effort for implementation monad and arrow hierarchy. And the goal is to compare how many functions should be implemented and how many laws. I think this slide is not really important. First it's arrow and applicative. I compare function and laws. Next one is arrow and monad like extension of application, applicative functor. And this is a summary. Yeah, and generally efforts it's enough equal. It means that it doesn't matter. That you can see that, for example, in case of we should to implement ID and compose, it's already implemented in pre-def. Yeah. For arrow, we should to implement arrow and first. It's two methods. And for KLEISLI, we should to implement flat map. Here, for functor map, can be easily implemented by applicative and monad with up and flat map. And that arrow and minimal laws for arrow and for monad hierarchy is the same, and the difference only in choosing basis for what we start to implement, composition or application of function with side effect. It means that for arrow hierarchy, that basis is a composition of function with side effect. For monad hierarchy, it's application. No, it means that it's flat mapped. But in any case, you should to implement only, in other words, two natural transformation, eta and nu. It means that reducing of arity and up to the monad. For any monadic category. It means that for here and here, we should implement flat map. Something like flat map. Here it's important, it's composition, here it's application. If put together hierarchy of arrow and monads, you can see a lot of the functionality intersection. And I mean that many structures can be used for the same purpose. Yeah, that like alternative, like extension of applicative, arrow plus, like extension of arrow, or monad plus, like extension of monad. And the final choice should be always based on the goals, maybe, and expressiveness of code. After all, code should be concise and readable. Yeah, it's maybe the basis for choosing what approach you will use. Maybe that after all, yeah, few arrows example and user of benefit for user arrows for our users, and for all who has a dream to be a train dispatcher. At this moment, you are really in one step from your dream. Yeah. Since that we will talk about railway-oriented programming. I like this metaphor, and I first time met it in Scott Washington blog, and I think, and it's good reflects the sense of approach. Yeah. If we have a function track, yeah, like in diagram, we should to care about a composition of steps, what can rise arrows, yeah, and about a single tracks function, yeah, or that end function, and handle both tracks. Yeah. First, it's errors. Yeah, few our function can have errors, and in arrow framework we have error handling. Second, it's we have some single track like update or send email. Yeah. Okay. Next one, it's that end function. Yeah, like send email. What's return nothing? No, it should return nothing. Yeah. And last one, it's supervisory function. It's last one where we should merge previous result, maybe it's error, with update database result. Yeah. And it is very well-known programming paradigm. It's named data flow programming. Yeah. And back to the code. If you have that currently that I little bit adopt my functions and have user case class the same like before, have a function get user by ID, yeah, and it will return either, because my arrow really good works with either. Not mine, it's framework arrows. And first it's arrow, another with user, yeah. Update with arrow and update name, for example, and send email with return times unit. I define some additional, it's already defined in predef, but I want to show it's identity function, it's left identity, and first function for a tuple. Yeah. And how our track, after all, can look like for if you have no monadic implementation of either, but we have it in Scala Z. Yeah. If we have no this implementation, it means for us it will be a composition of function. First one, get user by ID, what can return either. Yeah. Second one, update name. It's a single track function. It means that I want to apply this function only for the right value. It means that left value it will be error, and I not apply this for error. Next one, I need to send email, but email nothing to return. But I want to keep my user. It means that it's ID for user. It's this function, identity function. It means what's composed with send email and take a first parameter, because result of this one it will be will be a function, and function will be a tuple, and I want to get a first one. It means that I compose with first extractor here. I get first one, and it also should be applied for the right, only for the right, because left it can be error. And last one, I want to merge, and it means that if it will be left, I not want something to do with previous error. It means that it's left ID, and you see that left ID is just ID, but wrapped with the left. Yeah. And with update user, and after all, I have either error integer. And if I want to extract, it can be a pattern matching or something else, what wish, or folding, or some what after all. And it means that error or result. If I have monadic implementation for our either class, yeah, it means that I can use a COMBINATORS arrow. It means that just you can see this is nothing changed here, but result of this function, it will be either of error user, and I want to apply another function what get a user. Where is my this would get a user and return error integer, and I can use monadic implementation. It means that I wrap my previous function with COMBINATORS. Either here I should to fully show the type, because this type is not really easy to infer. And after I use composition for COMBINATORS arrow and have the same result after all. It means that two steps back. Yeah. It means that we have this houses our track. It means that all of our function represented here, we compose it in natural way with avoid of some errors and solve problem with that end, and have after all have final few implementation. One is with monadic, but here it's about a composition of COMBINATORS arrows. This is about a composition of simple arrows. Arrow in the simple types. I think I should show that maybe materials, maybe that if you see that, yeah, it's initially, it's maybe that it's initial article, that some material before, but this is one is initial, and as you see, it's about 20 years ago, that introduction, have a good introduction and material about that. And you can also find good material in the blog, maybe that I really like the Basij Gosh blog, and he shows how to work with domain-driven development with functional approach, which means that he tried to keep a functional approach for, and try to use a composition, prefer to another one, and some monadic usage of the Basij. Monadic usage and COMBINATORS arrow usage. Maybe it's related to F#, but I also recommend this guy. It's called Lashin. Really good definition of data flow programming. Maybe that also I recommend you, maybe that last one, it's Programming Cafe by Bartos. It's the same arrows in C++. It means that this concept, it's not Haskell. If you look to these articles, you can see that this concept of the arrows, it's very old concept, it's very useful. And if you look to the Haskell code, you can find many usages. But in Scala, it's not so popular. Maybe it's because that combinators looks like a funny, like a tanks or something like that. And after all, I'm ready to answer to your question, if you have. Yep. Yeah.
What would you say that this approach for this arrow scales up if I have more than 2 side weights or 3 side weights to manage in my problem? I mean, I see here you have a couple of functions that manage for me the information that I'm not so happy about. So say I can easily code the happy path, and I have the information that I don't want to process often is in the sideways. But I see, maybe I didn't understand it quite correctly, but I see 2 or 3 side paths, And it doesn't seem so nice when I have 7 or 8 side paths. I would go to an object and push it there and don't want to see it. What happened here is more and more operators just to get the types right and to process this. How do you think about this?
Yeah. I think you mentioned few. Yeah. I think you mentioned that here that I should write. Yeah. Use something like a write, move to the, and yes, that in any case that if you have a single side effect, maybe it looks like incomparable to monads, it's a little bit complicated. But if here I have a different types of error, here it's an error of database like a reading error, here it's error of database like writing error. And here it means that either I should to merge to either with a different initial left. It means that I can't do that. It's manual with any kind of monadic way. Yeah. And here you should to define how to you manage your previous errors. Yes, with CLEISLI arrow you not need to cover it because it's quite natural. No, because it's monadic way to use. But maybe that in any case. That most program, it's a 2 pass, it's enough. Yeah, but I would to say that if you have a more than 2 pass, you can easily reduce it with this operator, something like that. Yeah, it's folding operator, and it means that you can reduce your errors if you have more than 3 passes, or more than. In any case, you have a possibilities to. After all, you have possibilities to create that I use only 2 paths for shows what is happen, but in any case it can be more. It can be as 3, because for example, if we back to our common hierarchy, we have a different approach. I think it's font is small, but we have a different approaches. Yeah, here is, for example, you say about arrow choice. Here we have a monad choice for solving the same problem. Yep. Here we have a monad fix for something cycle in our graphs. I think how can I say it? It's in any case it should be that final approach of use arrow. Here I not want to say that you should use arrow everywhere. I want to say that if you see that code with arrows will be simplest and more shortest or more usable, use arrows. And I want to introduce more combinators for because it's still not used. I don't know why. Yep. Any other questions?
Yes. Moments? Excuse me.
You said that the arrows are very useful for handling side effects. But as far as Scala doesn't force side effects on type level, like Haskell does, for instance, what's the real gain apart from syntactical, fanciness and sugar and that kind of stuff?
Okay, that in any case we always try to wrap our side effect. Yeah, that it's a different kind of side effect. It's possible. Yes, we in any case that when your function return a list, it means that you return your function have a side effect. It's return more than one parameter. We not expect that from function for a natural function. For a function from mathematical point of view, it means that it's side effect of function. Or if function return nothing, we wrap these results. Yeah, we emulate our that in any case list option either not. Yeah, future. They emulate monadic behavior. They try to wrap side effect inside and provide the common simple interface like a flat map, not more. And in any case, we have a possibility to work with function with side effect, and we have it, and we use it in every program. We use it, and we create it. And the difference between a monad and arrows, that monad it's apply function for a container with side effect, but arrows, it's composed function with side effect. It's only one difference. It means that when you have a monad, for example, option, after all, if you apply by float map another morphism for your option, you have option as result. For arrow, you have a function was return a list, yeah, and another function won't return an option or something like that, and you compose or list, yeah. No, list and option is really good composable. And after all, you have a function, not a single, like in case of monad, we have a option, and after we have an option. For arrow, we have a function, and after have a function. It means that from functional point of view, it's not about the best choice or not choice, but from functional point of view, it's more natural to, how to say it, no, we emulate the same with EO monads, with what for make a computation laziness, yeah. It means that in any case we have a side effect, in any case we work with it, and it's only difference, it's composition or application function, no, binding side effect.
Any more questions?
Yeah, if no any question, then I want to.
This is your last chance, these Scala days, so.
Be involved.
Okay.
Okay. I want to say thank you for.
Yeah. Great.